This is Commodore, an autonomous AI SRE platform for Kubernetes, powered by me, Klaudia AI, to automatically visualize, troubleshoot, and optimize cloud-native environments at scale. Let's start with the clusters page. Designed for Kubernetes operators, it captures all the Kubernetes clusters integrated with Commodore and their current status, providing a high-level overview of your entire multi-cloud, multi-cluster environment in a single pane of glass. Using workspaces, you can easily scope Commodore's view by environment, cluster, team, or application. We can see that this production cluster, which runs on AWS, has multiple issues and risks that affect its reliability score. Let's dive into this cluster to see what's wrong. Inside the Health Overview screen, Commodore surfaces everything that affects the performance, reliability, and resiliency of this cluster, and the workloads that run on top of it. Commodore also analyzes the cluster's resource consumption and cost efficiency. Commodore integrates out of the box with every part of your stack, from APM tools to source control, and from CRDs to databases and workflow engines, connecting millions of disparate data points in the right context. You can see the full list of supported integrations on the add-ons marketplace. Each add-on gets its own view, including the ability to investigate these resources using a dedicated SME Klaudia agent. We'll now cover a few workload issues and how Commodore helps resolve them. Let's check out this unhealthy ledger writer service. The service page provides a unified view of workload activity, including all changes, events, and failures. It also allows you to access the pods, the logs, the metrics, and other information about this service. Let's click on the latest failure to understand what happened. When I detect an issue, I trigger multiple expert AI agents to get to the bottom of what happened and why. Then I suggest ways to resolve it. Commodore provides a clear and structured output to explain the issue, including a reasoning graph. In this case, the issue was caused by a typo in an environment variable. I suggest a one-click remediation action in order to close the loop and fix the issue. After fixing the typo in the environment variable name, I will restart the service to make sure it's working properly. Now I'm going to create a permanent fix for the issue using the GitHub MCP. Finally, I'll commit these changes to the source code. And done. For our next example, let's review the front-end app, which has many failing sessions. Another way to interact with Commodore is by triggering Klaudia chat and asking me questions in a free-form conversation. You can simply write something like, "Many of my sessions are failing, please investigate." I will then trigger a full-on investigation and showcase how I utilize the other Klaudia agents to perform a rapid and accurate RCA end-to-end. I will now trigger an investigation to get to the root cause of the issue. We can see that in this case, we have a cascading failure causing front-end issues due to a misconfigured network policy. Under the hood, you can see that I investigated the issue together with the Datadog agent that fetched traces and metrics for me, as well as a number of other Klaudia SME agents, like the PostgreSQL and knowledge base agents, to reach the root cause. We can see that we have a dependency between various components in this service, and to make the service healthy again, we need to patch the resource for the network policy to enable the user service to interact with the database. Now I will monitor the patch to ensure that the applied fix did in fact make the front-end service healthy. And it did. Perfect. Now I will show you how I can automatically remediate issues with no human in the loop. Here we have an app deployed from a Docker Hub image. The app failed to start due to rate limits with Docker Hub. I automatically identified that this image is also available in ECR and updated the deployment to use it instead. Inside the Klaudia AI menu, self-healing policies are configured in a fine-grained way, allowing for setting up what I can and cannot do. All self-healing actions are audited and can be traced back. In addition to that, organizations can easily extend my context with an internal knowledge base integration and an architectural blueprint. Commodore also helps ensure you run your environments cost-effectively, using three main pillars: cost attribution or allocation, workload right-sizing, and pod placement. You can customize your own key pricing parameters and discounts, and configure headroom to ensure your workloads can be scheduled quickly without waiting for new infrastructure to spin up. Right-sizing, automatic or manual, is easily configured with fine-grained policies. Recommendations are built based on health signals, combined with actual usage data to ensure maximum reliability at minimal cost. Pod placement enhances your native Kubernetes scheduler and node autoscalers with smart scheduling, reducing wasted capacity and optimizing cluster utilization. Commodore achieves this through automation and continuous environmental simulation, adding preferred affinity rules to improve bin packing. Commodore also analyzes your environments and surfaces inefficiencies to help drive an optimal state without compromising reliability, removing blockers like misconfigured node pools or workloads that lead to resource waste. This was just a small subset of Commodore's AI SRE capabilities. To learn more and see Commodore in action, go to commodore.com.